Hello and welcome to the AI Digest. My name is Joaquin Melara, and with me today is Dr. Cogan Shimizu. Hey Kogan, how you doing?
Pretty all right. How about yourself?
I'd like to say the same.
Well,
So
manifest
Kogan,
it.
yes, I'm great. I'm beautiful. I'm healthy. I'm wealthy. Uh, Kogan, you are an assistant professor at Wright State University, and
hmm
you are an expert in knowledge engineering, knowledge graphs, ontologies, computer science at large, but more on the symbolic side. Is that correct?
Yes.
What are you working on right now?
Oh, all sorts of things. So I have a couple of different research trajectories right now, largely focused on how do you use knowledge graphs in ways that support these huge deep learning or neural learning systems. So you have this neat knowledge graph, and we have these neat and powerful ways of extracting information from large data sets. But now, how do you guarantee correctness or improve confidence or certainty by using the sort of structured and maybe, shall I say, ontologically correct knowledge that would be contained in a knowledge graph in ways to improve the overall performance of these neural reasoning systems? Some specific examples kind of span a bunch of different domains, because my favorite thing is to not work in computer science, but to learn about all of the different things that people are doing elsewhere. So we have some neat projects that are pending right now concerning the material science, manufacturing. So it's how do you use a knowledge graph to model particular scenarios and then use it with swarm intelligence or fleets of robots that need to speak with each other, and they have different robot or different sensing mechanisms or different ways of interacting with the world. One of the key ways to managing these heterogeneous data sets is through a knowledge graph or through an ontology. And you can make things, sensors, robots, machines, services, all talk to each other through this shared medium, which we would call that KG. And making things, like constructing things, this requires multiple different machines, multiple different ways of interacting with the world and measuring the outcomes. And if you can have a shared conceptualization of the world, either through an ontology or through some neuro-symbolic mechanism, you can come up with some really neat ways to force systems to work together with a shared understanding of the world. All of the different ways that you can do that across manufacturing, different physical sciences, even different parts of computer science where you're looking at just sensor observations. This is where I'm focusing right
That's it. Just that.
now. Keeping busy.
Make it sound easy, man. Graph neural networks in conjunction with knowledge graphs and applying that to different industries so that you can, yeah, unlock an interface between the real world and the symbolic world, right? Create these self-learning, self-adjusting systems.
Well, hopefully, we're not quite there yet. We're getting there, but that's the goal: being able to learn about the world and reason at it in such a way that there's this empirical data, this observational data, where you're essentially learning the physical characteristics of the world, right? And humans, and you can see this even in toddlers, right? They explore physically their space, and then as they age, as they mature, you start bringing into this sort of abstract reasoning, right? And this is very obviously a simplification, and I'm sure a neuroscientist, especially developmental neuroscientists, would be really upset with some of these simplifications. But essentially, you start with just data collection, and then you move into these sorts of ways of formulating abstract conceptualizations about the world, right? Where certain colors indicate different things. Darker colors tend to mean shadows, right? For example, and these are human associative rules that make it a little bit easier for us to interpret the immense amount of visual information or auditory information. Quieter things, for example, far away, right? It's these sorts of rules which are hard to conceptualize from a data standpoint, but have this sort of fuzzy mechanism for us to interpret. This level where we dictate that sort of procedural or human abstract level knowledge, that's the ontology side of things of what I do.
So you're presently based out of Ohio, and if you're not in Ohio, you're flying out all over the U.S. and Europe to do research and collaborations. Is this an association with the neuro-symbolic graph neural network engines, or a multitude of things?
All sorts of things, right? So a lot of it tends to be visiting other institutions to work closely one-on-one, figure out, have a nice little meeting and catch up with some old friends sometimes, and just have a nice one-on-one where we're working together in close proximity on a single problem. Sometimes there are conferences, which is both networking and collaboration, or starting the collaboration, right? And also dissemination, so trying to announce the results of our other projects. And then, of course, there's the project meetings where you go and you meet your current collaborators and go report your findings to the people who are paying you.
Must be important. So, okay, we've talked about a little bit of what you do. I remember one time you invited me so very graciously to one of the lectures you were delivering on modular ontology engineering. To me, that just sounds like a different flavor of ontology engineering. It's like diet ontology engineering. So can you tell me a little bit more about this different flavor?
Sure. So ontology engineering is broadly the use of ontology to do different things. So there's ontology modeling, there's ontology alignment. These are probably the two most visible sort of subsets of what we would call ontology engineering. I'm going to focus very specifically on ontology modeling, and then even more specifically on modular ontology modeling. So ontology modeling or ontology development is the sort of mechanism by which humans create ontology, right? And this is an extremely expensive process because you normally need to sit down with the domain expert, you need to sit down with the ontologist, you need to spend the time to catch up the domain expert to the ontology knowledge and the ontologist to the domain knowledge. And then somewhere in the middle, there's static or lightning, and voila, you have an ontology after you spend a lot of time together. Modular ontology engineering attempts to solve or mitigate, I suppose, this expensive process, right? We want to try and reduce the amount of time and reduce the amount of friction that is spent in just the one-on-ones talking between highly educated people, of course, right? But people who are perhaps isolated or siloed into their own sorts of specific knowledge, right? The modular aspect comes from our principled use of what we call ontology design patterns. These are pretty old by now. Well, old in computer science terms, so somewhere in 2008, 2009 timeframes, where it's the prepackaged use or prepackaged model of a particular domain invariant modeling problem, right? So the notion of an event is pretty consistent across most use cases, or there's only a finite number of ways that are pretty common to model an event. You can think of it in terms of, oh, this happened, or in another way, oh, somebody recorded that this happened, right? And so there's participants in these events, and they all tend to have some notion of time, and they all happen in some space, right? And very minimally, that's what an event is. And so an ontology design pattern can be considered to be the packaging of these minimal conceptualization of a particular modeling problem. The purpose of this then is to start with these ontology design patterns, with these minimum things, and say, this is our starting spot. Instead of having no starting spot when you start with from first principles or from scratch or from nothing, we start with the ontology design pattern, some of which can be a lot more sophisticated than this this event conceptualization. So don't get me wrong, it's a little bit more than that, but it's hard to kind of do just here online, right? Where it's okay, we have a starting spot, and we can attach it to other design patterns very quickly. So if there's an agent design pattern and an event design pattern, and maybe some sort of way of commonly describing deliverables or publications, right there you have a scientific knowledge graph, just very, very basic one, but it took about 40 seconds to make, instead of coming up, well, here's an author and what are things about the authors and so on. But instead you have the design patterns that kind of guide the thinking to say, okay, these are the things that you need to put together, or that you need to think about during your ontology making phase, and then you stick them together, and then you're done.
I think a healthy exercise to go through right now is to sort of paint the scenario and showcase the transformation that occurs when you implement these methodologies that you're suggesting. So under normal circumstances, Kogan Shimizu would be the subject matter expert, if I'm the ontologist, I'd be interviewing you and sort of drilling into your mind what it means to be working in a particular area. What are the events? What are the actors? What are the actions? The steps in between, methodologies, all these words, all these ideas, all this knowledge. I have to kind of like drill it out of your mind and put it on paper and then model it on a computer program. But it doesn't matter what kind of expert I'm interfacing with. There are these meta patterns where things happen. And you're suggesting that if we were to have this Lego block system, that we can sort of take these templates of how things usually happen, that would be a good starting point to scaffold, rather than have a 20-hour engagement with a subject matter expert, maybe make it a 2-hour engagement just to build a proof of concept and extend it and then adapt it, which is far easier than to build everything from scratch.
Mm-hmm. Yeah, that's exactly it. Very well said.
So, yeah, where's this work taking you? Where can we find it? Where is the modular ontology engineering pattern library?
So yeah, good question. There's two ways that you can find modular ontology design. Well, the first one is in the sorts of deliverables that you use to, or artifacts, I suppose, that you use to conduct the modular ontology modeling. And then on the other hand, there's where has it already been used. I'll talk about the first. We have this collection of ontology design patterns, which we call model, MODL, for the Modular Ontology Design Library. And it's a small collection of well-curated, very commonly used design patterns that span a few meta patterns. So kind of like, how do you just model specific types of, not even specific types of things, but modeling strategies. So less even about abstracts. The most abstract way that you can get is domain and even pattern agnostic. It's just a stratagem for modeling anything. And then there's things about time and space and information and how you would encode attribution or provenance and these sorts of things. This is model version 0.1. We started this work pre-COVID, so it's taken us a little bit of time to sort of recover from that and get back on track. We have a second version forthcoming later this year. All of this is on GitHub. I'll pass Joaquin a link to these to share later, perhaps, and go from there. In addition to this, to the model as it exists as just this collection, we have a graphical tool that allows you to very easily and visually construct these knowledge graph schema or these ontology purely by dragging and dropping these different patterns onto a little canvas. And then because this is implemented as a plugin to Protege, which is an ontology editor, it will also formalize under the hood your picture into a fully functioning ontology under the hood. This is also freely publicly available for use in any in any way. It's open source, and I'll pass Joaquin the link to this as well.
Yeah, so essentially, Protege is a Stanford-backed graphical ontology development tool. I can get the plugin for this pattern library that you're constructing, and I can just drag and drop these puzzle pieces, these Lego blocks, and generate or spin off a pretty easy scaffolded uh, starting point for the ontology. Then I can go and showcase this blueprint to the subject matter experts and draw out any further refinements as required for extension, for alignment, for correction, for anything like that. Cool. Well, I mean, this is just one of the projects that you have in your portfolio of research and development efforts. How about we talk a little bit about the nowhere graph?
Sure. So the nowhere graph it's huge. It's this it's a massive, publicly available and open source, of course, graph that contains geospatial knowledge across the board, nationwide and globally, in some cases. The nowhere graph is a geospatial backbone between over 30 different region data sets and different geospatial phenomena such as earthquakes, droughts, storm events, declared emergencies from FEMA, logistics information, and then also softer things like human systems pertaining to determinants of health, social determinants of health, judicial districts and outcomes. And then we flip back to the more political things, such as like where are states and counties or countries and the sort of administrative or bureaucratic units across the world and nation. It's built using the modular ontology modeling methodology. So it is a modular schema for the knowledge graph, which combines which allows us to replace or add new data as they come in very quickly. It's a very cool project. It's probably the largest openly available geospatial knowledge graph in the world. It's close to one of the largest publicly available knowledge graphs, period. Open source, publicly available.
So let me just get this straight. I mean, governments and different organizations, they just produce data. I mean, I think that's a statistic that we're kind of bored of hearing. Every day we produce more and more data. The more sensors, the more advancements, the more data we produce. Is that usable data? Is it in a format that is interfaceable? Is it in a format that any citizen scientist can go and interface with in the current format that it stands? Probably not. I don't think people like downloading gigantic spreadsheets with hundreds of thousands of potentially, um, potentially missing data points or just like dubious forms of information. So what you guys have done is you've taken all these different data sets and combined them into a unified model that then represents and integrates these data sets into a knowledge graph that you can interface via a Sparkle endpoint, right?
Yeah, there's also a collection of different tools that we've used to make this easier. Sparkle, for all its strength and ability to get you nice, correct answers, is also annoying and complex, not particularly easy to read all of the time. So we have a lot more, shall we say, approachable tools that make it easier to interface with nowhere graph, because the by necessity nowhere graph is complex and very, very rich in its data layers. So we have a faceted search mechanism, for example, which allows us to quickly pare down the visible part of the graph to the things that are most useful to the person using the search mechanism. So a faceted search is very similar to, I'm sure we've all used Amazon Prime or Newegg or something, where you click on the left-hand corner, the checkboxes of the things that you want to look at, right? Oh, it was made by this manufacturer, or was has this much memory in its internal storage, and so on. We do the same thing. It's we want to know about the geospatial phenomena. We want to know about the events or the people that live in a specific place. So you look at, you click this particular county or this zip code, and it will just summarize it for you. It's very neat. In addition to the faceted search mechanism, we have our plugins for the common geospatial or geoinformation science tools. So we have ArcGIS and QGIS. We have functioning plugins for that, which allow us to query the graph and display them immediately inside of the tools that analysts and geo analysts use on a daily basis. Yeah, I think those are the big ones.
So I think I think what we're trying to say, and let me just state it from my own words, and then you can rectify if I'm misunderstanding, is there were previously data sets. They were all over the place. They were not being used. You integrated them into one place. You have this master data management ontology as a schema. It's open source. You have tools that support this interfacing with this large data set, one of the largest ones in the world, with multiple layers of information. You could go to the technical realm, which is kind of like a hellhole via Sparkle endpoints, or you could use the more graphical, user interface friendly faceted search. But nonetheless, you would probably still be able to get some sort of API interface or dump data as required, right?
Yes. We offer a data dump, basically in these early stages of the project by request, and then the API is homomorphic to a Sparkle endpoint. So it's really just, I wouldn't go so far as to say it's a hellhole. It's just, it requires necessary domain expertise and a little bit of practice to use Sparkle appropriately. It's kind of like using the command line in your operating system. It can be quite complex, but after you get a little bit of practice in it, it's very powerful. It's the same way, I think, with Sparkle.
Let me say that a little bit more tactfully. For an everyday citizen who maybe may or may not have access to a level of understanding with SQL, for them to go and tackle a different interface syntax, Sparkle for graph-based data science, it's another layer of obfuscation of learning a new syntax. But in addition to that, it's also introducing the complexity of this already complex knowledge graph, all this schema, right? Because you said there's over 30 different sources of data. So to bind 30 sources of data from different domains, in my very simple-minded perspective, seems like a Herculean effort, to put it mildly. So that's what I meant by hellish endeavor.
Yeah,
But
no, I think it's fair. Yeah.
But if you're already like a domain expert, and this is just like you're trying to just meet the technical requirement of gathering this data, the faceted search should be sufficient. And I'm sure that the Nowhere Graph team also provides a point of contact that has an idea of what they're looking for and can provide further assistance or training if required for any proof of concepts that are being made, like outside of just a cosmetic search to get an idea of what's in there, right?
Yeah, we are very happy to identify people who want to work with our data, with the graph overall. We have our own website called nowheregraph.org, and there's contact information and a lot more descriptions of the different tools that we offer and the actual technical documentation of the schema as well.
So this nowhere graph, you said that there are government agencies that kind of contribute information to it, people that are sort of just dipping their toes into it. What about the proof of concepts that have to do with the real world? I know this is doing important work in building the infrastructure, consolidating these data sets, making it accessible through a usable interface that provides some sort of consistent output. So that's really, really important work. But is there anyone out in the world that is presently using this for some sort of low-level proof of concept project?
Yeah, so there's two ways that we can look at this. One is with our nonprofit collaborator, Direct Relief, who's been with us from the very beginning, helping us guide in what are usable or what they would find useful in the sort of data that we integrate, as well as the sort of tool interface that would be useful in the hands of a non-ontologist or a non-knowledge graph expert, but somebody who's deeply embedded in their own domain and use cases. They're particularly concerned with identifying experts and people who have been involved with the sort of, to reuse your word from earlier, Herculean task of overcoming past disasters, right? The earthquake in Turkey from last year, or the war front in Ukraine, or any of the sort of epidemics that are occurring all over the world. They're interested in ensuring that they have the right people for the right jobs at the right time. So they use nowhere graph data in order to identify the sorts of people to contact and who to put in place for these disaster scenarios. In addition to this, the nowhere graph is acting as the geospatial backbone for the National Science Foundation's prototype open knowledge network, which is a massively funded program that is encouraging, or funding, I suppose, the formulation of 15 additional huge knowledge graphs that affect, that are human and societally, citizenry, meaningful problems such as wildlife management, neighborhood safety, safe access to water, energy, and many others, cybersecurity, logistics, things that impact the general populace. And they all, in many ways, intersect with the geospatial side, because that's where people live. People live in time and space. And things that impact them impact time and space. And so every single one of these projects have a mechanism by which they mediate through this geospatial component. And nowhere graph is serving that need right now.
You said something that we haven't yet defined: open knowledge networks. So my understanding of open knowledge networks is like linked open data. Linked open data is publicly available data that has some sort of graph format. Would these open knowledge networks be the knowledge graph equivalent to that? So you create a particular domain of expertise for a sector that is available for the government and for the public use, so that people can sort of break off and have one unified, federated way of engaging with that domain.
Yes, yeah, there's a good definition there. And then the open knowledge network is supposed to be many of these different knowledge graphs working together through a few touch points of shared vocabulary where necessary, such that you can query one place. The query by one place is generally powered by two teams, Spider and Frink. Can pass you contact information and other details later, where they provide a federated access to the rest of the OKN. And because we are using a shared shared vocabularies and shared identifiers where possible. You can chain and you can learn about different entities as they exist across these different projects. So the easiest one for me to talk about is place, right? These projects are housed in different universities across the nation, but sometimes they are in similar places. There's 2 teams, 3 teams, I think, in Indiana, or certainly as that many in the Midwest. And having shared identifiers for the cities in the Midwest allows us to say, okay, well, here's the wildlife management aspects of Columbus, Ohio. Here's the neighborhood safety aspects of Columbus, Ohio. Here's the water access for Columbus, Ohio. And because everybody talks about Columbus, Ohio in the same way, irrespective of the people's effort, we now have 3 they integrate along a common geospatial backbone, giving us a pretty holistic understanding of what it's like to live or provide decision-making information for legislators or policymakers. It's a very ambitious project, but it's also very cool.
That's interesting. So you know, there's so many different layers of knowledge, and everybody sees the world in a different way based on their understanding of the world, based on their level of knowledge, based on their immediate context. What you're saying is that in order to coordinate this very complex effort, Herculean task in the intellectual realm and the mental models, yeah, everybody agreed to one unified way of identifying the thing that they're going to talk about, and then they decided to layer on top of that the specific knowledge that they have on that thing. So one agency might be concerned with air quality for a specific geographical location, but they're using one shared unique identifier, right, across all spectrums of that thing. Another entity, another group may be concerned with the water conservation efforts. Another group might be concerned with the soil health or the soil nutrition, but they're all referencing the same thing with the same shared unique identifier.
Yes, that's exactly it. Within the United States, the NOAA graph offers and maintains, in fact, the geonames in genus, the geonames identification service. I'm probably misremembering the acronym, which is provided by the USGS, which provides the US government, for example, with these consistent names. And what we've done is we've allowed, you have a linked data or a knowledge graph version of genus, which is provided to the rest of the Proto-OKN, and they use that as their shared namespace for places, amongst others.
I like that you said that everything happens in time and space. The one static thing that we have in this world, as long as it remains a sphere, is latitude and longitude, and it makes sense to map according to those static points because everything else is not static. Plants grow and die. Natural disasters reshape the face of the earth all the time. Um, Climate changes, time changes, people move, people are born, people die. There's actions, there's events, but the one thing that remains static throughout time and actions and events is the dang place, the latitude and longitude. So that's a good, that's a smart way of anchoring this whole effort.
Thanks. Yeah, I agree. Which is why we're doing it. So
So yeah, where are we going next? What's in store for Cogan and his merry troop of researchers?
Oh, that's a very interesting question. So at the very beginning, I talked about some of the research projects that we're hoping to do. So what's next is we do them one way or another, cross-funded or just getting those projects funded in one way or another. Like I said, I'm very interested in these sorts of use cases where we blend the physical world with a shared conceptualization from the ontological level. Because this is, at least superficially, this is how humans tend to interact, right? They have a shared incoming data stream, which we might call just audio, visual, tactile for now, just to kind of constrain even minimally that incoming data. And then you have the abstract reasoning that runs on top, and how those two things interact with each other. This abstract reasoning plus this extraction of meaningful results out of large scale data in a semantically, ontologically meaningful way is really an open question. I'm really excited for the future, because this is, I think, very much the path towards artificial generalized intelligence. We have a really cool dog stool seminar coming up in 2025, mid Q2, Q3, something like this, on neuro-symbolic AI and recent advances. So we're keeping an eye on that. We're really driving this forward.
Going back to that modular engineering, modular ontology engineering, as a means to enable neurosymbolic applications. Yeah, what kind of domains are you dipping your toes into, and how do you see yourself propagating this against new domains?
So right now we have three projects with different modular ontologies specified. So one of them, of course, is nowhere graph, and another is enslaved.org, which is a large knowledge graph which attempts and in many ways succeeds in capturing the stories of the historic slave trade. So trying to tell the stories and track down the lineages and the lives of the people who were captured, enslaved, and bought and sold in the Caribbean and the Americas. This ontology that we've used is modular for this, to try and capture the sort of he says, she says, it was written here, it was written there, on these different sorts of records and so on, and has gone through many evolutions and is now in a place where it's shared. You can find it at enslaved.org. It's really impactful place to see all of the different data captured from old rotting records taken out of old missionaries left to the elements, and have that data extracted and then lifted into a knowledge graph that anybody can query and learn about their own pasts or their family or histories, or how just people were impacted in those years. In a complete flip, we are also looking at modular knowledge graphs for representing educational material. So if you have these days, books, especially college textbooks, are extremely expensive, right? But there's such a wealth of information out on the internet, on YouTube, in articles and blog posts and so on. This is another form of heterogeneous information, right? It comes in different formats. It's accessible in different ways, but they can be unified on topics, right? So if you have a topic identifier, such as pulled from Wikidata or something, you can interlink the different sorts of educational materials about specific topics. And now you can start making, if you start capturing metadata about where they came from or who made them, you can make guesses, or sometimes it's directly encoded on, is this beginner or intermediate or expert level knowledge? If it comes from a scientific paper, it's probably, but not always, expert knowledge. If it's coming from a blog post, it's generally meant to be approachable. There's licensing information, of course, and all of this, and integrating this all together so you can just ask the knowledge graph, hey, show me all of the educational material related to Sparkle in order of approachability, right? And so it should be able to give you exactly what I just said. Here's a blog post. Here's a video tutorial, and here's some of the theoretical underpinnings of Sparkle all in a row. So that way it's this sort of ad hoc lesson plan. Now, the interesting thing comes in once you have knowledge in this form, in this structured format. What's to say we can't use something like a large language model powered agent and some sort of retrieval augmented generation to say, hey, teach me about Sparkle. And what it does is it goes to this curriculum knowledge graph and it pulls exactly the data, exactly the educational material that is inside of that curriculum knowledge graph, and then can assemble a much more human meaningful lesson plan or curriculum on Sparkle. That's that I think is the frontier of where we're at right now as a lab in terms of at least one of our projects. It's pretty, one way or another, we're doing that.
Two questions.
Yeah.
As you take that breath, I'm gonna jump in there. For one, it's this modular ontology, having patterns, having things that are sort of recurring, seems more structurally sound as a way to construct systems. I mean, just thinking about it from a physical realm, triangles are shapes, squares are shapes, different shapes have different levels of integrity for distributing or pushing weight across, how things are being used. So I'm only thinking conceptually, some part of that bearing needs to be true. Logically, will you be also producing some effort into making human constructed ontologies backwards compatible with these modular ontologies, so you can sort of refactor things that have already been constructed so that they're in a more pattern friendly form?
Ideally, I think the answer is yes. The best way to go about this tends to be a human process. This any sort of ontological refactoring is exceptionally difficult.
Yeah.
Even with 10, 15 years now of dedicated research into it, it's still very much an open problem on how to align different sorts of knowledge, right? There's the holy grail of ontology alignment is called complex alignment or complex ontology alignment, where you have very tricky ways of mapping between conceptualizations. I think the standard example is professor, right? An assistant professor could be its own standalone concept, right? Just a single square in your schema. On the other hand, somebody else might say, well, there's a professor concept, and that professor has a rank assistant, right? So this is a little bit more general way of talking about professorship, because you just have one notion of professorship and you have different ranks, and now the ranks are divorced from the notion of professing, shall we say. And how do you say that these two things are equal? How do you automatically do this? It's very, very much an open question. There's some recent work in using large language models to do this human-like reasoning for this. But it turns out that humans are also terrible at this. There is also some work done by one of my colleagues who looked at creating a human benchmark of ontology alignment. Which of these two concepts, or how would you arrange these things to be equivalent? And this was executed on some crowdsourcing platforms and then some experiments in person, and humans did terribly. So it's really difficult to say how we can do these sorts of refactoring automatically. I guess that's a little bit of a downer way to end that particular piece of the conversation. But I guess what I would say now is, if you're going to make a new ontology, if you're going to make a new knowledge graph, take a look at using the ontology design patterns first instead of not. And that way we can kind of have this reusability and this interoperability from the get-go instead of having to worry about refactoring later.
No, that's fair enough. I don't think that's a Debbie Downer view. I think it's a very realistic Richard way to look at things. Yeah, I mean, knowledge engineering is hard. Knowledge is subject to expert opinion and experiences. And if the people that were used to construct that ontology are not in the room, if they're dead or if they're inaccessible, you lose a lot of the context behind why things were arranged in a particular way. You know it works, you just don't know why it works at the mechanical level in that way, in that configuration. And it makes sense. I mean, that's just the way that the world works. You have an organization, you have a group of people in a tribe, you have hunters and gatherers. You got the one guy that goes collect herbs, and that guy gets mauled by a tiger. Nobody knows what herbs he was collecting or from where or how he identified whether they were good or bad. Um, he drew some pictures, but that's not nearly good enough. You don't have his expertise.
Yeah.
That leads me to the second thing that I wanted to say. Something that's really been in my mind, and I just see that as a boon to mankind. You know, first you have this concept of a book. A book is a reservoir of knowledge. People take their experiences, their thoughts, they make an outline, they write, they crystallize their thoughts in a book, and then there are libraries. Libraries are reservoirs of books, and they have the Dewey Decimal System, a taxonomy to organize and classify different areas of knowledge. But these are like batteries, and batteries that you have to make contact with your eyes and make contact with a piece of paper so that you can understand how to process that information. Having an interface between a library and a person and all the books, whether it's like you scan all the documents and you have computer vision, parse out what each letter means and construct them into words and what those words mean and translate it into a digital format. And then you have some way to like digest all of it and have provenance. So, you know, this book here has this metadata and talks about these things. It was written by this author at this year. Doing that curriculum interface is something that would be really beneficial for mankind. And not just from the educational standpoint, but from the cultural standpoint as well. You know, dead languages, going to museums and talking to the philosophers in English, modern English, you know, from ancient Greek. I mean, those are leaps and bounds in what we can accomplish, but we really should be trying to figure out a way to do rather than all these other commercial efforts. You know, we need to really get a pulse check on where we came from and where we're going.
For sure. Yeah, the notion of using a knowledge graph and perhaps some sort of generative language model in order to learn how old or ancient or even current or contemporary, I suppose, uh, agents or authors or performers or whatever, how they would react to certain things is simultaneously exciting and terrifying, right? It's the how what's the boundary between being dead long enough that one of these agents becomes interesting instead of a violation of rights or imagery. um it's basically in the same way. It's a very interesting analog to the deep fake situation, right? If you deep fake Henry VIII, this is not so much of a problem, right? If you deep fake our sitting president, this is much more of a problem in some ways, right? And in the same way that we're doing this with authors and so on, where's the boundary for this? And I think this AI data ethics piece is very very, very much something that we must continue to keep an eye on.
I fully 100% agree with you. Can we use that knowledge? Yes. Should we use that knowledge? It depends. Um, who do we represent or who do we mock? It depends. I'm all for mocking politicians. Just not when it's a life critical misrepresentation of something. But yeah, all this construction of knowledge and representation of knowledge, making it human and machine interoperable, that's a precursor for the neuro-symbolic work you're doing as well, right?
Yes, yeah, very much so. So trying to bridge between the sort of physical and the data driven and the abstract or symbolic side. So very much trying to connect behavior to action or behavior to observation and so on. It's very much within the purview of neuro-symbolic AI.
At some point, we're going to get so good at transporting and reusing knowledge, we're going to be able to scan a book, turn that into an ontology or a knowledge graph, compare it with a representation of the world, maybe a generative language model, and then use that as a underlying symbolic representation that you embed to the sensors or whatever it is that you're thinking of using to build that neurosymbolic system. No?
I am not sure if I followed there. So yes, there's definitely the use the book to learn the knowledge, or perhaps a little bit more um, on a shorter time scale, reading a new scientific paper, right? A new chemical or a new protein is found and published about. There's hundreds of these sorts of papers published every day, more than any one human can learn, right? This is the sales pitch for IBM Watson, in essence, right? How do you learn new knowledge from these rapidly published, or if not rapidly, but rapidly from the perspective of a single person? How are these published? And then updating or incorporating this new knowledge rapidly in such a way that you can then affect change in the real world. Suggest a new drug cocktail to treat a specific type of cancer, these sorts of things. And that requires both a statistical understanding of is this likely to work, as well as a symbolic understanding of, yes, this known pathway for a particular treatment is known to the medical community, and so therefore would be appropriate to suggest this thing. And so even that sort of fusion between the sub-symbolic and the symbolic results in a neuro-symbolic architecture.
How far away do you think we are until we can get something like this in a production environment, a neurosymbolic system?
That's a really good question, because I think these sorts of neurosymbolic systems exist already, but in limited forms. Maybe the grander ones are not there yet. You can consider the retrieval augmented generation of a large language model to structured knowledge. This is in some ways already neurosymbolic, whether or not it's exactly the vision that we want. It remains, I think, up for both interpretation and hindsight for now. This is also, yeah, but trying to incorporate these the knowledge graph with the ontology, with the recommendation, or not the recommendation, with a recommender, which is statistically or sub-symbolically or machine learning driven. This is still an open question, but a question that's being addressed very, very rapidly across the scientific communities.
What about from your standpoint? Like, how far away do you think you are from implementing something that could be used by a pilot, like in some small way?
You like a pilot that flies a plane?
Like a proof of concept, something that you
Oh, that
implement
sort of pilot, yes.
to provide some value as a recommender, as an agent, as a assistant, that has access to a proprietary database and access to outside information and can reason and provide those recommendations proactively. Maybe even like a weather channel reporter or something like that. I don't know.
Yeah, that's a good question. It feels like we are very close and very far away at the same time. So it's a little bit of a non-answer because there's this notion, right, of unknown unknowns. I have an idea of how this might look like in terms of I'm very focused right now on the educational assistant, right? I
Mhm.
want something that I can teach my students. About Sparkle, about something, but I'm not always around and I'm not always going to be around, especially after the course is over, right? But they should be able to have access to maybe not me or even a clone of me, but something that has roughly the same sort of breadth and depth of knowledge that I have in a particular knowledge engineering concept. And what this would allow us to do is say, okay, I can't answer your question right now, but go check with the virtual tutor, and the virtual tutor should be able to respond with these questions by generating some response from the structured symbolic knowledge and then package it into nice human readable language from whatever generative language model exists for this purpose. In some ways, we'll probably have this within a year or so. In other ways, it's hard to say. Maybe the large language model does not handle the generative aspect of educational text very well, and it's hard to say. Should ask me again next year.
That's an invitation for a second interview. I assume.
Yeah,
Um,
sure. Yeah.
cool, Kogan. Well, you're doing a lot of interesting work, and you're at the bleeding edge, absolute bleeding edge of all these things. Anything you want to tell the public? Don't freak out. Things are a lot further away than they actually are being hyped up in marketing channels.
Yeah. Um, yeah, that's always a little tricky. Yeah, it's better to be cagey. It's better to be untrusting of where you think the AI is. It's not in such a place right now, and from my perspective, that it's going to replace everyone's job. We're simply not there yet. There's a lot of talk on how it perhaps replaces the lowest common denominator, but only in the absolute easiest of tasks, and then even then, it's still liable to screw up, and you may as well still employ humans doing these sorts of tasks, even if they're tedious or whatever. Um, it is a rapidly changing field, though, so hopefully next time or this year, next time, I still say the same thing, that it's still far off, that we're going to get replaced or whatever. Um, but yeah, always fact check, always double check any generated code. Yeah, the current state of AI is very fallible, and don't believe otherwise.
I know we're all kind of foaming at the mouth, like rabid dogs, looking to get faster and faster and smarter and smarter. Is there any area that you think we should take a round turn? Is that the word? Yeah. Is there anywhere you think we should turn around and go back to like a slower pace so that we can acclimate ourselves to the rate of change, especially around this rapidly evolving field? Like anything that we need to go look at the root at or root of a particular idea?
Um, that's a harder question for me to answer, and I would not particularly feel comfortable expressing my non-expert opinion there, because I have a very myopic view of what we are, of how the LLMs or how AI is used these days. In my particular field, I think we're still very safe. It tends to be looking at it, it's a sort of chicken and an egg problem, because you run into these we need to contemplate how integrating data, for example, that is anonymized in shards, right? This data set has information about person A, but it never refers to them as person A, right? And this other data set has different information also about person A, but never refers to them as person A. If you put them together, can you identify who person A is? Right? This sort of de-anonymization by accident, by simply integrating multiple pieces of data, is very much problematic. This is very important for knowledge graphs as we start putting together structured knowledge in exactly the same way that a recommender system, Google, Facebook, Meta, whatever, kind of track people across the internet, across different advertising data sets. We don't want to accidentally do this with the high quality public data either, because then it becomes a sort of unsafe place when it should be this publicly open data.
Last question, and I promise this is the very last one. Any pieces of advice for someone who's getting started in academia, research, that sort of has this idea of making an impact in the world through advanced knowledge and wants to follow somehow in your footsteps?
Ooh, that's always a tricky question. Academia is simultaneously an extremely gratifying role, or being a professor or a research professor is, because you are working on the things that you want to work on, that you think are going to make an impact to the world, or that you find that are interesting and that you're passionate about. For better or for worse, it is also thankless, because you have to teach kids and kids so frequently don't they have the things that are important to them in their life too, right? And what the professor thinks is important and what the student thinks is important, not always eye to eye, right? But on the other hand, and I say that partially in jest, it's thankless insofar that sometimes research is being done for research's sake, and sometimes research that you've completed is not always immediately apparent how it's going to turn into capital that can be leveraged, or improve a particular product. And you, because of that, and because of the vitriol that can be directed towards this perceived notion of, oh, it doesn't produce value, there needs to be some sort of passion for you or for whoever wants to study. And it's hard to say that if you want to make an impact in the world from the perspective of research or from academia, it should never be a question of, oh, do I want to get my PhD? If you don't know if you want to get your PhD, you probably don't want your PhD. It is very broad advice that I would not say this is applicable to everyone. But if you're teetering on whether or not to get it or not, there are many more ways to contribute academically or be impactful than going through academia and getting your PhD, because it can be it can be a lot of stress and a lot of work. And yeah, I don't know. There's probably a much pithier way of saying that, but it's always trying to encourage or never discourage, but be realistic about the academic journey from in postgrad is a problem that's very dear to me, but probably has I could just keep talking for forever. So I'll leave it with, think very carefully about it, and if you think too hard, that's probably an indication of something.
I think throughout the whole interview, you've meant to say a lot of the times. It depends, and it ain't so easy. So
Yeah,
I think this is one of those times. Kogan, Dr. Kogan Shimizu, it's been a pleasure to have you.
absolutely. Thank you
Yeah,
for having me.
we'll do this again next year.
Yeah, looking forward to it. Have a great day.